Hey guys, all right, we're going to be taking a look at lab math here. This is going to coincide with what we talked about a little bit in chapter 1, and this is going to go along with the lab math lecture. Okay, so in this tutorial, make sure you print off the lab math video tutorial worksheet on module 2, and then you can use that to follow along with the problems I'm going to do here on the whiteboard with you all. This will kind of be really helpful to give you a basis of how each one of these problems are done in real time, instead of just trying to work through them by yourselves, even though I'm sure you can probably figure them out, but just to give you a little bit more of a background on them and a little extra help. So we're going to start off here with part 1, which is going to be figuring gram molecular weight, and that's often abbreviated GMW, okay, gram molecular weight. This is real easy to do. Okay, so in our first one here, it wants us to figure what is the gram molecular weight of KOH. Okay, so we have KOH, which is potassium hydroxide. So essentially, we're just going to add up all of the elemental atomic weights. So in this chemical here, we've got potassium, which has an atomic weight, and you can print off the periodic table there on module 2 to help you with this. We have a atomic weight of 39.09, oxygen, atomic weight of 15.99, and then hydrogen, atomic weight of, we'll just do 1.00, okay? And then you essentially just add all of those up, and all of those up is going to come to a GMW of 56.08, and that is your answer. Okay, so pretty simple on that, not too bad. All right, now let's go a little bit further with that, and let's say we have a compounded chemical. Okay, so let's look at Na3OH4. Oh, that's supposed to be a sub 4. So sodium, that has an atomic weight of 22.99. But since we have 3 of them on here, we're going to have to times that by 3, okay? And we have an oxygen. Oxygen, again, at a 15.99, so that's good. We just have one of those. And then our hydrogen, we have 1.00. And since we've got a sub 4, we're going to have to times that one by 4 also. So up here, that's going to give us a 45.98, and then down here is just a 4.00. So we're going to add this plus this plus this, and that's going to give us a gram molecular weight of 65.97. And again, that's just adding this, this, and this. So that is our gram molecular weight when we have compounded chemicals. Okay? So pretty simple to figure those. All right. Now, our next one here is going to be calculating molarity of a solution. So we have how many grams of Na3OH4 would you need to make a 2-liter solution? 2 liters of a 0.3 molar solution. So the first thing you have to do is you have to figure the gram molecular weight of that Na3OH4. Okay, so let's go Na3OH sub 4. So Na has a atomic weight again of 22.99. Oxygen, we just have one of those, so it's going to be a 15.99. And then a hydrogen, that is going to be 1.00, but times 4 on that one, and then times 3 on that, okay? So you're going to times 22.99 times 3, that's going to give you your value, okay? And then we're going to just add all those up again, and that's going to come to 88.96, okay? So that's our gram molecular weight for this chemical compound there. Now, to figure out the actual molar solution, we've got to take into account the 2 liters total and then the 0.3 molar solution, okay? So we're going to do over here 0.300, and we're going to times that by our 2 liters, okay? And then X grams, that's what we don't know, over our gram molecular weight, which is 88.96, okay? So the first thing we're going to do is we're going to times these two together. So that's going to give you a 0.600 X over 88.96. All right. So then we're just going to substitute that there out, and that's going to go 0.6 times 88.96, and X is going to equal 53.38. So you're just running them down. And again, remember, you've got to remember your order of operations, obviously. So figure your 2 in your parentheses first, that times them by the 0.8 or 88.96 gram molecular weight, and that's going to give us a final value of 53.38. And that is going to be how you figure molarity of a solution. Now, after we've got that, so there's our answer. So what if we want to know how to finish off that particular solution? So we got to be able to weigh out 53.38 grams, 53.38 grams of Na3OH4, okay? And then we're going to place that a 2-liter flask. Always choose a flask or a receiving container that's going to be as much or more than what the quantity is you're trying to make, okay? And then we're going to dissolve this in a little bit of reagent water. So dissolve 53.38 grams of Na3OH4 in reagent water. Okay? And then we're going to fill, so you could use, 10 liters, whatever the case may be, or 50 milliliters, or however much, just to get this into solution, okay? And then after you have this dissolved in your flask, you can finish filling the flask to the calibrated 2-liter mark. And that's going to give you your final working reagent, okay? So remember that you have to start out with, you have to know that, that molarity value. All right, now we're going to take a look at our percent solutions. These are also referred to as solution dilutions, but this is going to start on part 3 on your video tutorial worksheet here. So it says how many grams of potassium chloride are needed to make a 65% weight over weight solution using DI water as the solvent. So we see that we have 65%, okay? It's always going to be over 100. It's always going to be over 100. So with a weight over weight, we know that it's going to be 100 grams of solution. And then when you divide that out, that's going to leave you with 65 grams of KCl. Pretty simple. Those aren't too bad, okay? So now if you were going to actually make this, how would you finish that off? So you're going to dissolve this into 35 grams of DiH2O. So you would have to weigh out your potassium chloride, weigh out your water, add those together, and then that's going to give you your 100 grams of solution. Okay, so that would be your final working reagent. All right, so that is a weight over weight, as it's designated in that fashion. So there is also weight over volume. So weight over volume is going to be, let's say we have, what is the weight over volume of solution that has 35 grams of sodium chloride? So 35 grams over volume is going to be in milliliters. So 100 milliliters of solution. Okay, so that's going to leave you with 35% of NaCl. So let's ask ourselves, how would we go about finishing off this particular solution? So we're going to dissolve the 35 grams of NaCl into 100 milliliters of DI water. Okay, so our final volume is always going to be 100, so it's going to be 100 milliliters. So you're not going to change from that in this. You're going to take that 35 grams and dissolve it into that, and 35 of 100 is going to be 35%. Okay, so percent per 100. All right. Okay, so that's weight over volume. Now the last one is going to be volume over volume. Volume over volume. So how many milliliters of potassium chloride to make a 20% volume over volume solution? So start off with 20. And again, that's going to be 100 milliliters again, because it's a volume we're working with. So that is going to be 20 milliliters of KCl. So how would we finish this one off? This one's a little bit different. So amount of solvent, which is going to be our total, okay? So this little formula, amount of solvent equals 100, which is our whole, okay, minus 20, which is what our figure is. So this is our solution, and this is our solute, okay, and our solvent. So remember that the solute is going to be the formed matter, the formed material, the particulate matter of a liquid. The liquid portion of that is going to be the solvent, what the solute is dissolved into, okay? So that is going to leave us with 80. So X being 80, you're going to have 20 milliliters of KCl plus 80 milliliters of DiH2O. And if you look at this, that is going to give you 100 milliliters total. So you're still going to be at a 100 whole. It's still going to be percent, a 1 whole. Okay, so you're 100 milliliters. All right. Now to kind of take this a little bit further, let's say that you are asked to make up a 40 milliliters of a 25% volume over volume concentrated KCl solution. So how would you go about doing this? You're going to use a ratio. Okay, so 25 over 100. So X, which is our unknown, that's what we're trying to find out, over our 40. So our 40 milliliters, and then our 25% solution, our 100 milliliter whole, we need to know how much of that unknown we need to use, okay? So that's going to be, you just basically cross multiply. So 100x times 1,000, and then you just solve for x. That's going to give you 10. So x is 10 milliliters. So you would add 10 milliliters of KCl to a, your measuring receptacle, a flask usually. And then add reagent H2O to the calibrated (100 milliliter mark. So if you add to that milliliter mark, 100 milliliter mark, that is going to be your whole. Okay? So 10 milliliters, then add your 100 milliliters up to your 100 milliliter mark with your DI water, and that's going to give you your finished or your final concentration. All right? So, on the following page here, we got concentration calculations. Now, these are actually one of the I'm not going to say the very few calculations that you have to do, but these are one of the more common calculations that you might have to perform in a chemistry lab, okay? So it's asking you a solution with 500 milliliters of a 5% weight over volume potassium hydroxide is needed for some sort of test you're running, okay? In your stock room, you notice that you have a 20% weight over volume solution of potassium hydroxide. How many milliliters of that 20% weight over volume potassium hydroxide solution are needed to make a 5% weight over volume solution? So this is going to be done using the formula C1, V1, C2, V2. So this is going to be the stock concentration, this is going to be the stock volume, this is going to be the new concentration, and then the new volume. Okay, so if we go back to our problem here, we just start plugging in the numbers. Okay, so our C1 is going to be our 20%, because that is our stock room. Okay, that is the what we have available. All right, so 20. So put that in our parentheses. Now our V1, our stock reagent, we don't know that yet. That's what we're trying to figure out. So that gets an X. All right, our concentration of our new reagent. So that's going to be the 5. We know that. It tells us that in the problem. 500 milliliters of a 5% solution. And then the milliliter or the amount that we're needing is going to be that 500. Right? So then you just start multiplying. So we got 20x on this side. 5 times 500, that's going to give you 2,500. Take that times 20, or divided by 20. X is going to give you 125 milliliters, okay? So now, to make your final reagent, you're going to have to take this 125 milliliters of the 20% solution. So 125 milliliters of the 20% solution are diluted with your reagent water to a total volume, whatever the new volume is you're needing. In this case, it's going to be the 500. 500 milliliters, okay? So those are C1, V1, C2, V2. They're concentration calculations. Those are pretty commonly used in the lab, actually. I use those quite a bit whenever I was in micro, believe it or not. So you can actually see those. All right, so the last one we're going to talk about is figuring absorbance from percent transmittance. Okay, these are really easy calculations to do. So let's say, for instance, it gives you the percent T result of 39%. Okay, So 39% T. So now we need to calculate absorbance from that. So in order to do that, we're going to use 2 minus log percent T. So we're going to type in 39 in our calculator. So hit 39 and then hit the log button on your calculator. That's going to give you a value of 1.59. Okay? So then we're going to take 2 minus 1.59, and that's going to give us a 0.41 absorbance reading. So those are pretty simple. All right, so that's going to conclude this little tutorial. I hope it was a little bit more informative rather than just hear me talk through the video lectures, and it helped give you guys a little bit better idea on some of these calculations. If you got any questions, get a hold of me at any time, and I'll talk to you guys soon.